going to talk about the chain rule today. We need the chain rule when we have a composition of two functions. So the idea here is we have an inner and an outer function. So we need what's called the chain rule. So suppose we have y equals f of g of x. Our derivative here says that we are going to take the derivative of the outer function, which we call f, and keep the inner function g of x inside of it as is. And then we're going to chain along, meaning multiply along the derivative of the inside. So in this example, the outer function is f, the inner function is g. Okay? So it means to take the derivative of the outer function with the inner function inside of it. Remember to chain along the derivative of the inside. So let's look at several examples where you can see this in action. So with our first one here, we're going to do this one multiple ways. If we were to use our chain rule, we can go right to our derivative. We're going to multiply that 2 down in front. We're left with 2x plus 5 on the inside. The 2x plus 5 is the inner function. I just took the derivative of the outer function. Okay, so I multiplied down, I subtracted 1. And now I'm going to chain along the derivative of this inside piece, which would give me 2. And if I were to clean this up, I have 4 times 2x plus 5, which would give me 8x plus 20. We could also do this using the product rule. If I were to use my product rule, we have y equals 2x plus 5 times another 2x plus 5. From there, if we were to do our product rule, the derivative of the first, keep the second one the same, plus reverse what we just did. It's going to end up being the same thing. Notice if we were to then clean this up, we would have a total of 8x and then plus 20. So it's the same thing. And the last way, if we were to use the power rule. So if we were to simplify this function, if we were to multiply it out, we would have 4x squared. And then we would have, again, what I'm doing here, we have 2x plus 5 times another 2x plus 5. If I multiply that out, I would have a total of 20 x's on the inside and the outside when I combined them, plus 25. And then from there, if I went straight to my derivative, 8x plus 20. So notice how we're getting it 3 different ways. Okay, well, our focus of this video, though, is the chain rule. You're not always going to be able to do it multiple ways. So, take a look at example number 2. There's only really, realistically, one way to do this, and that is the chain rule. So we're going to multiply that 10 down in front, carry along the inside, okay, subtract 1, so our new power is 9, chain along the derivative of the inside, which is going to be 2. So if your inside is linear, then it's just going to be that number in front of x. So we can multiply the 10 and the 2 to get 20. We have 2x plus 5 to the 9th for our simplified final answer. Okay, next one here we have a radical. And with this one, we're going to first rewrite this as 2x plus 5 to the 1/2 power. So now I'm ready for my derivative. Again, multiply down. So we're doing the derivative of the outer function. Okay, so that's really your power rule. And then, once again, chaining along the derivative of the inside, which is 2. Well, that 1/2 and that 2 will give us 1. We're left with 2x plus 5 to the negative 1/2, which is the same as 1 over 2x plus 5 to the positive 1/2, which is really the square root of that. So if this is on AP and it's a multiple choice question, odds are you'll see it in that form. Our next example here, let's take a look at this a couple different ways. Let's use first the chain rule. Now if I'm going to use the chain rule, I'm going to need to bring up this 4x minus 3. Now right now, as is, it's really raised to a power of 1. So if I were to bring this up, it's now raised to a power of negative 1. So notice that's still equal to y. So now, if I have brought that up, I could use my chain rule. So multiply down, we have 4x minus 3 on the inside, subtract 1, we have negative 2, and we're chaining along a 4, which is the derivative of the inside. So that gives us negative 8 times the quantity 4x minus 3 to the negative 2, which is the same as expressing this as negative 8 over 4x minus 3 to the positive 2. The other way is we could use the chain rule. We could use the quotient rule. Okay, so I'm going to do my quotient rule here. Going back to the original. Low D high is the first part. So low D high, well that would give me 0. Minus high D low would be 4 all over low squared. Well, notice that your numerator simplifies to negative 8, and that's going to give you the same thing as before. Alright, on to some other examples. It's not always going to be linear on the inside, as we see in example 5 here. We're going to multiply our 3 down in front, so we keep the inside the same. Okay, our new power would be 2. And I'm going to chain along the derivative of the inside. So it's not linear, so you just have to think about what the derivative would be. Well, it would be 6x minus 2. Just find your normal derivative of the inside. The only thing you can do to simplify this would be to multiply this 3 by that 6x minus 2. So that's 18x minus 6. And then this 3x squared minus 2x plus 1 squared, think of that term as being untouchable. Can't multiply anything into it. So this would be our final answer. So next one here, same idea. Multiply that 2/3 down. We have 7 minus 4x squared as the inside function. Subtract 1 to your power, now you're at negative 1/3. Okay, and now we have to chain along the derivative of the inside, which would be negative 8x. Notice it's not linear. The derivative of 7 would just be 0, and then the derivative of negative 4x squared is negative 8x. Not much you could really do to clean this up, other than to multiply 2/3 and negative 8x together. So that's negative 16x over 3, and then 7 minus 4x squared to the negative 1/3. Okay, you may actually see it written like this: negative 16x all over 3 times. Now I could turn this into a cube root of 7 minus 4x squared and put it in the denominator. Again, if this is an AP multiple choice question, odds are that's how you're going to see it left. Okay, remember, a 1/3 power is really a cube root. Let's look at a couple more examples here. With number 7, we need to do some prep work here. This is the same as replacing that radical with x squared minus 4x plus 1 to the 1/2 power. From there, you're going to multiply that 1/2 down, so you'd have negative 5 over 2. X squared minus 4x plus 1 comes along for the ride. Subtract 1 to your power, and you have negative 1/2. And like before, we're going to chain along the derivative of the inside, which would be 2x minus 4. Okay, we'll leave that one where it is. Number 8, if you see a fraction like this, you could always bring up your denominator. Now, this 4th root is really the same as a 1/4 power. So if I bring up 6x minus 1 and I want to get rid of that 4th root, it's going to become a negative 1 over 4. Okay? So now I'm ready for my derivative. I'm going to multiply down. That's going to give me a positive 1/2 times 6x minus 1. Subtract 1 to negative 1/4. It's the same as subtracting 4 over 4, so now you're at negative 5 over 4. And we're chaining along the derivative of the inside, which would be 6. Multiply 6 and 1/2 together, you have 3. And then 6x minus 1 to the negative 5 over 4. We'll leave our answer at that. Alright, we're going to jump down here to example number 10. So we want to be careful here. You cannot multiply, in this example, this 4 down in front to that x squared. The only time you can multiply that 4 down in front is if there is no additional x term right there. So the only time you can multiply that 4 down in front is when there is no variable, which is usually x, in front. So there has to be a constant. Okay? So if there were a 5 in front, you can multiply that 4 down. So instead, what we're going to have to do is treat these two parts as two separate functions. And we're going to need our product rule. Okay? Because we have a product of two functions. So we have 2x, that's the derivative of x squared, times 2x minus 3 to the 4th. That's the first half of my product rule. The second half is to keep the first function the same. And now I have to multiply by the derivative of the second function. Well, this is where we're going to need our chain rule. So the 4 is going to get multiplied down in front times 2x minus 3 to the power of 3. And then I'm going to have to chain along my derivative here, which would be a 2. And from there we could certainly simplify it if we had to. Okay? And we will stop there for now.